Hello, Algebra 2. Well, actually not Algebra 2. Hello, College Algebra. This is the lesson over scientific notation. As you see before you, you have a very large number and a very small number, and each one have a ton of zeros. And we don't really like writing a lot of zeros. Do we really have to write all those zeros for the answer? And I'm here to tell you, no, you do not have to write all those zeros. There is another way to rewrite these numbers, and it is called scientific notation. Some of you may have heard of scientific notation before, probably from a chemistry class, a physics class, or any high science class in general. If you have not been introduced to scientific notation before, let me give you a quick run through. The formal definition of scientific notation is notation that uses properties of exponents to rewrite very large and very small numbers in a less clumsy form. And there's usually two parts to scientific notation. The first part is a number in the front, and specifically this number has to be between 1 and 10. So say, for example, off the top of my head, I'm going to write the number 2.5 for A. And this is a number between 1 and 10, so it would work. The second part of scientific notation is multiplying by 10 to the power of a number. So like say, for example, right behind the 2.5, I'll write times 10 to the power of 7. This would be an example of a number in scientific notation. And actually, if you type this number in your calculator, 2.5 times 10 to the 7th, you would actually get this number, 2, 5, and then 6 zeros. So in other words, this number is the same thing as this number, only this number was a lot easier to write than just rewriting all of these zeros. So there you go. This is what scientific notation looks like. Just a number between 1 and 10 in the front times 10 to a power of a number. And that'll take care of rewriting all those zeros. It'll save you so much more time. So now that you get familiar with scientific notation, let's look at some more examples. So let's say on the next slide, I give you two numbers written in scientific notation, and I ask that you rewrite them in their original form. And typically one way you can do it is just plug both of these into your calculator and solve it that way. But there actually is an easier way. And all it takes is moving this decimal. And you either move it to the right or to the left, depending on your power. So in other words, for the first example, 2.78 times 10 to the 6, take a look at your power of 6 and notice that it's positive. If it's positive, that means I'm going to be moving my decimal to the right. And how many times do I move it to the right? I'm going to move it 6 to the right because my power is 6. So let's go ahead and just do that over here. 2.78, and I'm going to take the decimal and move it over 6 places to the right. 1, 2, 3, 4, 5, 6. And all those spots where I didn't have a number, just replace them with zeros. And voila, you have what the original number looked like. So again, this number is the same as this number. And all you had to do to rewrite it was move the decimal 6 places to the right. The second example is very similar. Only if you notice here, the power is now negative. And if you have a negative power, that means when you move the decimal, you're actually going to move it to the left this time. So in other words, this decimal, since we have a negative power, to rewrite it, you're going to move 6 spaces to the left. So let's go ahead and just do that over here on the side. 2.78. I'm going to take my decimal and I'm going to move it 6 spaces to the left. 1, 2, 3, 4, 5, 6. And in all those spaces, fill them in with zeros. And there you go. That's the original answer. 0.00000278. And there you go. So in the online homework, if it gives you problems in scientific notation and asks you to rewrite them in their original form, all you literally have to do is take the decimal and move it left or right, depending if the power is positive or negative, just like that. A couple quick notes before I let you try an example on your own. There's usually a way to tell if your number is going to be large or small depending on the power. Like if you look at the first example, it says if the exponent is large or positive, then that means your number's magnitude is going to be large, or in this case, big. So I'd like to say, for example, if you notice that 7 is a positive number, then that should tell you that the original number is going to be big. And sure enough, if you were to take 9.3 times 10 to the 7, the positive 7 would tell you to take the decimal and move it over 7 places to the right. 1, 2, 3, 4, 5, 6, 7. And of course, if you fill in all those numbers or all those zeros, you should get 9300000. And sure enough, that is a big number that you'll get for your original answer. So again, if you have a positive number, your number is going to be big. And you can probably guess that's going to be the opposite if you have a negative power. Or in other words, if your power is small or negative, then your number's magnitude is going to be small. And again, translation. Take a look at this number. It's a negative power. And if it's negative, that means your final answer is going to be little. So in other words, typically for this example, let's say I had to move the decimal left or right, the negative would tell me I have to move it to the left, and specifically left 3 spaces. So let's go ahead and do that. 1, 2, 3. And fill in zeros in those places. And just so you know, if this negative is bothering you right here, you can go ahead and put it in the front. So go ahead and put that negative in the front and then write 0.0016. And sure enough, taking a look at that number, it is a very little number. So in other words, anytime your scientific notation has a negative power, that means your final answer is going to be a little number. Again, positive power means big number. Negative power means little number. If you get the hang of that, rewriting these should be a piece of cake. So now, moving on to the next slide, let's just try one more, acting like that, and then you can try some examples on your own. So let's say for this one, we got a number in scientific notation, and we got to rewrite it as a regular number. And take a look. That's a positive power, and positive means I need a big number when I rewrite it. And sure enough, if you were to take the decimal, and according to the positive power, that means we got to move it right 4. So 1, 2, 3, 4. Put zeros in those spots, and you'll have negative 79800. And even though it's negative, it is still a big negative number. And there you go. Positive power means big number. Moving on to the next example, we have to rewrite this in its original form. First, take a look at the power. It's a negative power, and negative powers means we're going to have a little answer. So let's go ahead and take a look at that. So negative power means I'm going to have to move to the left. And how many times will I move to the left? In this case, 5. So let's go ahead and do that. Take the decimal, let's move it over 5. 1, 2, 3, 4, 5. So a 0 here, 0 here, 0 here, 0 here. So that's going to be 4 zeros, and then 8, 5, 5. And that is definitely a little number. So if you get the hang of that, rewriting these is a piece of cake. Positive power means big answer. Negative power means little answer. All right, I think we've talked enough about those. Now I want you to try these examples on your own. On Edpuzzle, you have a chance to answer both of these questions, rewriting them into their standard original form. Go ahead and try those now. And then once you're done with both of them, you can check your work with mine. Go ahead and do that now. All right. So now you should have tried both of these on your own. To double check, again, you got negative power, which means you should have a little answer. And let's check. A negative power means we're going to have to move to the left. And you move to the left 3 units. So let's go ahead and do that. Take our decimal and move it 1, 2, 3. Put the zeros in those spots. And since we do have a negative, let's go ahead and move that to the front. So you get negative and then 0.00743. That should be the answer you got for rewriting that answer in its original form. Take a look at the next example. You have a positive power, which means you should have a big answer. And let's check. Give me a second to scroll this up. So positive means I'm going to have to move to the right, and I'm going to move to the right 5 units. So take the decimal and go 1, 2, 3, 4, 5. And we'll put zeros in those extra pockets. So then your big answer should be 986000. There you go. So rewriting numbers from scientific to standard is easy enough. But what if, say, we started with the number and we had to rewrite it in scientific? That's what we're going to do now. And this way is a bit more tricky. Here are typically the 3 steps to take a number and rewrite it in scientific notation. So let's say, for example, I have 0.000075, and I need to rewrite it into scientific notation. The first step that is stated here, it says move the decimal over left or right until the number is between 1 and 10. So it looks like I'm going to have to move the decimal over to the right until I can get it so that the number is between 1 and 10. So right here, that's 1 movement. We're not there. 2, not there. 3, not there. 4, not there. 5. If you move over 5, that means we get 7.5, which is definitely in between 1 and 10. And then we're just going to write that we moved 5 spaces to the right. Okay, So that's step 1. Step 2, count how many places you moved the decimal over. And we already did that. We said we moved 5 units to the right. Then look at the next sentence. Keep it positive if you moved left, make it negative if you moved right. And in this case, since we moved right, it means that we should make it negative since we moved to the right. So take those 5 units and make it -5. And that's step 2. Step 3, the number from step 2 is going to be your power for base 10. Or in other words, in scientific notation, when we write 10 to the power, our power is going to be -5 that we figured out from step 2. And the number in the front is the number we got from step 1, or in other words, 7.5. And once you've done that, congratulations, you have just rewritten a number in scientific notation. So let's try those 3 steps again with a different number, just so you get the hang of it. So now we're going to rewrite in scientific notation, we're going to rewrite this number. So step 1, we need to move the decimal over left or right until the number is between 1 and 10. And I don't see a decimal in this number, so I'm going to make one. I'm going to put the decimal right in the back. And now, let's move the decimal until the number is between 1 and 10. And it looks like I'm going to have to move it left to do that. So 1, 2, 3, getting closer. 4, 5, getting closer. 6, 7. Bingo. That gives us -2.6. Ignoring the negative, that is between 2.6 is between 1 and 10. The negative will work. And if we double check, we moved 1, 2, 3, 4, 5, 6, 7. We moved 7 to the left. All right, so that's step 1. Step 2, count the number of places you moved the decimal over, and we already did that, 7 to the left. And it says, the next sentence says, keep it positive if you moved left. And that we did. So in other words, the 7 will stay positive. So now moving on to step 3, the number from step 2 will be the power for the base 10. So the +7 becomes the power of 7. So that takes care of the first part. And in the second part, take the -2.6. And there you go. There's your answer. 2.6 times 10 to the 7. And some of you who've already worked with scientific notation before, this will be really easy. If you have trouble solving with powers, or if you have trouble with solving if the power is positive or negative for the base 10, my recommendation is trying this. If the number you start with is big, then that means your power is going to be positive. So let's say I give you 98600. As you can tell, that is a big number. And just like we talked about before, if you have a big number, that means that your scientific notation is going to have a positive power. And sure enough, if you rewrite 98600 in a scientific notation, this is actually what you're going to get. 9.86 times 10 to the power of 4. And sure enough, if you were to move that decimal over 4 units to the right, like we normally would, you would get the original big answer. So in other words, if you start with a big number, your scientific notation answer will have a positive power. And then you can probably guess it's opposite for the other way. If the number you start with is little, your answer will be negative. Like, for example, say I give you 0.00016. You can see that that is a little number. And when you think little, you should think negative power. And sure enough, if you were to rewrite this in scientific notation, you'll get 1.6 times 10 to the power of -4. And if you want to double check, if you were to take this decimal and move it over 7 places, you would get the original number that you started with. So again, when rewriting this, if you have a big number, then you'll have a positive power in the scientific notation. If you have a little number, you're going to have a negative power in the scientific notation answer. Keeping that in mind, these examples should be a piece of cake. So now, I want you to try these two on your own. Take these numbers and rewrite them into scientific notation. Go ahead and try that now with Edpuzzle. And once you've tried both of these examples, you can check your work with mine. Go ahead and try that now. All right, you should have tried it by now. So for this one, you notice that the decimal makes this a very small or little number, which means for scientific notation, you're going to have a negative power. Just going to go ahead and write that over there while we rewrite this. Okay, so first thing, we need to move this decimal over until we get a number between 1 and 10. So 1, 2, 3, 4. So that was 4 moves. So in other words, that means our number in the front will be negative 3.85. And that's between 1 and 10. So now we'll write times 10 to the power of 4, because we did 4 moves, but we got to make it negative because we started with a little number. And there you go. That's the answer in scientific notation. Now take a look at the second one, 232. And if you're not sure where the decimal is, make a new one. Usually the decimals are always in the back if you don't see them. So start off by noticing that we have a big number. And if we have a big number, that means positive power. Just going to make that note, and then let's continue. All right, so first, I got to move this decimal to get a number between 1 and 10. So 1, I'm getting close, 2, bingo, that'll work. 2 moves. And in 2 moves, I have rewritten the number as 2.32. And then times 10 to the power of 2. 2 because we moved the decimal twice. And if you look at the note at top, it has to be a positive power. And there you go. There's your answer in scientific notation. And right there, that's 70% of the online homework for scientific notation. Rewriting numbers from their original to scientific, and then vice versa. Easy enough. Just keep moving that decimal over, left and right, whichever way you need to. The other 30% of the lesson involves multiplying numbers in scientific notation. Or in other words, we got 3 numbers in scientific notation that need to be multiplied. That may seem a little intimidating at first, but it turns out we can actually break this up into parts so it's easier to solve. Give me a moment. I need to grab a cough drop, and then I'll show you what I'm talking about. Cough drop, cough drop. All right, I'm good. So the way we can break this up is we can first multiply the numbers in front together. Or in other words, you can just do 5 times 5.6 times 7. So if we do that real quick, 5 times 5.6 times 7 in the calculator, that gives you 196. That, just like that, you've just finished half of the problem. And now you're going to do the same thing with the base 10s. Or in other words, you're going to multiply 10 to the negative 7, 10 to the negative 10, and then the 10 to the negative 8. And you just multiply those together. And it turns out, if you remember from one of our original lessons, anytime you're multiplying powers of the same base, you can actually just add those powers together. And then in this case, that would become x to the 10. With these, you can do the same thing. Just take the negative 7, negative 10, negative 8, and just add them together. And when you do that, you should just get 196 times 10 to the power of negative 25. And just like that, most of the work is done. Now, I have to warn you here. Give me a second, I have to rewrite that. I have to warn you here. I've seen a lot of kids stop here, put that in as their answer, and then they end up getting it wrong. And the reason why this answer is not correct yet is because of this number. This number is not in between 1 and 10 yet. And the way to make it between 1 and 10 is to make a decimal and move it until it is. And in this case, we got to move it 2 places over. So 2 moves. And since we did 2 moves over, that means we have to add 2 moves to the power. So in other words, 196 now becomes 1.96. And then 10 to the power of negative 25 plus 2, which will make this negative 23. And then this would be your final answer. So that is something you will need to watch out for. Make sure that this number is between 1 and 10 before you enter your final answer. Let's try another example like that so you can get the hang of it. Now take a look at this example. So first things first, take care of the numbers. Just take care of those, multiply and divide, whatever you need to. On the top, you should get 3,200, and on bottom, you should get 16. And then 320 divided by 16 should give you 20. So that takes care of all the numbers in red. That part is done. Now, let's take care of the base 10s. So, I'm going to go ahead and just write that out first. On top, we got 10 to the 2, 10 cubed. On bottom, we got 10 to the negative 8, 10 to the negative 13. And my recommendation for solving this is I would take the negative powers and I would flip them to the top. It'll make your job so much easier. So if we do that, we'll get 20 times 10 squared, 10 cubed, and then 10 to the 8th that got flipped, and then 10 to the 13th that got flipped. So there you go, fractions all gone. And now all that's left for you is to add all those powers for the base 10, which should, give me a second, when you add all those together, you should get 20 times 10 to the power of, give me a moment, 2 plus 3 plus 8 plus 13, 26. Now take a look at that. Determine if this is the final answer or if we have to readjust. And sure enough, this number is not in between 1 and 10 yet. We got to move a decimal. So now it is between 2 and 10. And since that was one move, that means we got to add 1 power to the one that was before. So for our final answer, we should get 2.0 times 26 plus 1, which gives us 27 as our power. And that should be the final answer that you submit into your online homework. So that's really all there is to it. Multiply the numbers in red, then take care of the base 10s in blue, and then make sure that your front number is between 1 and 10, and readjust if needed. And then these problems are done. Piece of cake. So now I want you to try an example on your own. So take a look at this example, and through Edpuzzle, try this on your own. And then once you got it, check your work with mine, and then we'll continue. Go ahead and do that now. All right, you should have tried the example by now. So if you do the first thing is to multiply the numbers, or in this case, we'll multiply 4.5 and negative 6, and then we'll divide by 1.5. So 4.5 times negative 6, and then divide by 1.5. That'll actually end up getting you negative 18. All right, so that takes care of the numbers in red. Now let's take care of the base 10s in blue, which if we just rewrite formally now, they'll give us 10 to the negative 14, 10 cubed, and then 10 to the negative 7. And again, my recommendation before we continue, go ahead and flip any negative power. So the negative 7 will go to the top, the 10 to the negative 14 will go to the bottom. And once you've done that, then we'll readjust. Okay, so negative 18, and then times 10 to the 7 got flipped to the top, the 10 cubed stays where it is, and then 10 to the 14th is going to the bottom. And now let's simplify from there. So negative 18, I'm going to go ahead and first add the powers on top. So 7 plus 3 will give me 10 to the power of 10 on top. And then on bottom, I'll get 10 to the power of 14. And now notice this time we have division. When you're dividing bases of the same power, that means you got to subtract the powers. And let's go ahead and do that over here. Negative 18 times 10, and then we're going to subtract the 2 powers. And remember to subtract the top from the bottom. So 10 minus 14, which then if you rewrite that, will give you 10 to the negative 4. All right, looks like we're almost done. But then if you look at the negative 18, the 18 part is not in between 1 and 10 yet. So we got to move that decimal over one space. And we moved it over one space means we have to add a power of 1. And so that means our final answer, negative 1.8, with the 1.8 between 1 and 10, and then 10 to the power of negative 3. Because negative 4 plus 1 gives you negative 3. And that is the scientific notation answer that you will submit. And just like that, congratulations! You now know how to take care of numbers in scientific notation. So just some wrap-up points. Again, make sure the number in the front, it has to stay in between 1 and 10 for any scientific notation answer. And also on the online homework, please make sure you read the instructions. If it's asking for the standard answer, it's going to be looking for the normal answer. If it's looking for the scientific answer, it wants, well, the scientific notation answer. So in other words, 2.5 times 10 to the third in this case. So just read the instructions carefully and you should be all right. And also at the end of this lesson, I do have a cute little music video if you want to watch it. I'll attach a link to the Edpuzzle, and then you are officially done and you are officially ready to start the online homework. Thank you for watching, and I'll see you soon.